So we have to start this topic with an introduction to a couple of terms that are used over and over in chemistry. The first is an atom. No matter what material you're talking about, it's made of atoms. It's a little difficult to describe exactly what an atom is based on the material that you've already seen in science classes, but a fair analogy would be to say that atoms are like the bricks that all materials are made of. Not all atoms are the same. There are many different types of atoms. In fact, most materials that we deal with in day-to-day life are made of several different types of atoms. However, there are certain types of materials that are made up of only one type of atom. For instance, this penny is made up of billions and billions of atoms, but every one of those atoms is the same. This aluminum foil is made up of many atoms, but every one of these atoms is the same. However, the type of atom that makes up this penny is different from the type of atom that makes up this foil. The penny is made up of 100% copper atoms. The foil is made up of 100% aluminum atoms. The name for a material that's made up of only one type of atom is an element. Copper and aluminum are just two types of elements. There are over 100 known elements, and the way chemists keep track of them is in a chart called the periodic table. So here's an example of the periodic table. The overall shape of the periodic table and the information contained in it is always the same. However, the coloring of the blocks can be different based on who the publisher is, so don't pay attention to the colors in this particular periodic table too closely. Every block in this table represents an element, and every element has a 1 or 2 letter symbol that stands for the element. For instance, block 29 has the 2-letter symbol Cu, which stands for copper, while block 13 has the symbol Al, which stands for aluminum. Notice that these are just 2 of over 100 different elements. We'll be getting back to the periodic table in the next unit, but it helps to have a little orientation to it before we talk about atoms or elements. We're going to be spending a lot of time talking about atoms this semester. So what I want to do right here is just give a little introduction to what atoms are made of. So this is the cartoon of a sample atom. There are going to be some things about this representation of an atom that are true, and some things about it that are not so true. But I think it's a good place to start to give you a little bit of an orientation as to what goes on inside of an atom. The first thing you should notice is that the atom is made up of 3 different types of particles. You've probably noticed that there are blue circles, green circles, and red circles. You've probably also noticed that the blue and green circles are about the same size and that they're much larger than the red circles. The blue and green circles are also clustered towards the center of the atom, whereas the red circles are located on the outside. So let's go over what these circles represent. The green circle represents what's called a proton. The blue circle represents what's called a neutron, and the red circle represents what's called an electron. As we said before, the protons and the neutrons are clustered together in the center of the atom. This area in the center is what's called the nucleus. So again, this is a little bit of an oversimplification of what a real atom looks like, but there's a couple of really important concepts that this representation shows, so let's sum those up. First is that the protons and neutrons are clustered together in the center area called the nucleus. Next is that the electrons are located outside of the nucleus. Notice that the protons and the neutrons are about the same size. And finally, that the electrons are much smaller than either the protons or the neutrons. So this slide is going to recap some of the information that was contained on the previous slide, but it's also going to give some more specific information about the particles. First thing has to do with the size of the particles. So far we've mentioned that the protons and the neutrons are about the same size, but that they are both much larger than the electrons. Here, we're going to be a little bit more specific about the sizes of these particles. There's a unit that's used to describe exactly how large or small one of these particles is. It's called an AMU, which stands for atomic mass unit. Both a proton and a neutron are considered to have a mass of 1 AMU. In contrast, electrons are much smaller. They're considered to have a mass of approximately 0 AMU. This can be a little misleading because you might take this to mean that an electron has absolutely no weight. In reality, an electron just has a very, very small amount of weight compared to either a proton or a neutron. Specifically, the mass of a proton or a neutron is about 2,000 times greater than the mass of an electron. In saying why we consider an electron to have a mass of 0 AMU, I like to use the analogy of hair. Ask yourself, does hair have any weight? I think we all realize that if we put enough hair on a scale, it would definitely have a weight to it. But ask yourself, how much does the hair on the top of your head contribute to the overall weight of your body? If you weighed yourself before and after a haircut, would your weight be significantly different? I think we all realize that even though hair has weight, its weight is so small compared to the rest of your body that when thinking about your overall body weight, you can essentially think of hair as having no weight. That doesn't mean that hair has no weight at all, it's just it's really, really, really small compared to the rest of you. So just like hair, an electron does have some mass. It's just that the electron's mass, when you compare it to the mass of the protons and the neutrons, is so small that it doesn't affect the overall mass of the atom. The next thing we need to talk about is charge. We haven't talked about charge yet, but if you've ever touched an electrical wire and gotten a shock, you know a little bit about what electrical charge is. Electrical charge is what causes the sensation of the shock that you receive. Some of these particles in the atom have a charge. One thing about charges is that they can either be positive or negative. A proton has a charge of +1, or another way of saying that is +1. A neutron doesn't have any charge at all. Another way of saying that is that its charge is 0, or that it's neutral. Electrons, even though they're really small, have a charge of -1, or -1. The charges of these particles are very important in understanding why atoms behave the way they do. Please take the time to memorize the information contained in this slide, because you're going to be using it over and over the next couple weeks.